Before this video is over, something is going to click in your mind. The bowling ball you casually grab off the rack was never meant to roll straight down the lane. From the very first moment it was created, it was engineered to spin, curve, and strike with intention. All because of what's hidden deep inside it. It looks simple, it feels heavy, it seems ordinary, but beneath that smooth, shiny surface is a carefully designed system that decides how the ball will move long before it ever leaves your hand. Today, you're about to see exactly how a bowling ball is made, step by step, starting as a liquid material and ending as a perfectly balanced tool built to knock down pins with precision. And once you understand what's really inside, bowling will never feel like a simple game again. If you enjoy discovering how everyday objects are secretly engineered to perform the way they do, take a quick second to like this video and subscribe, because this channel breaks complex things down in a simple, interesting way. Now let's go back to where it all begins. Most people believe a bowling ball is just one solid piece of plastic. That assumption couldn't be more wrong. A modern bowling ball is made in layers, and every single layer has a specific purpose. At the very center of the ball is the most important component, the core. The core controls how fast the ball spins. It controls when the ball starts to curve, and it controls how powerful the impact is when the ball crashes into the pins. Wrapped around that core is the outer shell, known as the cover stock. This layer controls how much grip the ball has on the lane surface. Together, the core and the cover stock decide whether the ball glides smoothly down the lane or suddenly makes that sharp, aggressive hook right before impact. And believe it or not, everything about that motion starts long before the ball is ever made. It starts with designing the core. Engineers don't guess the shape of the core. Every detail is carefully planned using computer modeling and precision design, and these cores are never perfectly round. Some are stretched, some are uneven, some are intentionally off balance. That might sound strange, but there's a reason for it. Changing the shape and weight distribution of the core completely changes how the ball behaves while spinning at high speed. Even the smallest adjustment can affect when the ball turns, how sharply it hooks, and how strong the impact feels. That's why two bowling balls that look identical on the outside can feel completely different once they're in motion down the lane. Once the design is finalized, it's time to bring the core to life. Inside the factory, liquid materials like resins and polymer compounds are carefully measured and mixed together. At this point, nothing even resembles a bowling ball. The liquid mixture is then poured into specially shaped molds that match the exact core design. As the material hardens, it becomes dense, heavy, and incredibly precise. Some bowling balls use a single solid core, others use multiple layers, where one core is formed inside another to fine-tune balance, stability, and motion. This hidden structure is what gives every bowling ball its own personality. Once the core has fully hardened, it's ready to become part of an actual ball. The solid core is placed inside a much larger spherical mold. To keep it perfectly centered, a pin holds the core suspended in the middle. Then the outer material is poured in. This outer shell, known as the cover stock, is made from specially engineered compounds designed to interact with the lane surface. Some cover stocks create more friction and grip early. Others allow the ball to slide longer before making its move. And this outer layer plays a huge role in how the ball performs once it's thrown. As the liquid fills the mold, it completely wraps around the core, locking it inside permanently. Once it hardens, the mold opens. And suddenly, the rough shape of a bowling ball appears. But here's the catch. It's far from finished. When the pin holding the core is removed, it leaves behind a small hole. That tiny gap is filled with a colored plastic marker. And that little dot? It's not just decoration. It marks exactly where the core sits inside the ball. Professional drillers use this as a guide to place finger holes perfectly, making sure every ball performs exactly as intended. Now it's time for the machines to take over. The ball is mounted onto precision grinders, which slowly shave away any extra material. Step by step, it becomes a perfect sphere. Even the smallest imperfection could make the ball behave unpredictably at high speed. Accuracy here isn't optional, it's everything. Once the shape is flawless, the surface gets its final treatment. Some balls are sanded to create a rough texture, which grips the lane quickly. Others are polished to a glossy shine, allowing the ball to slide farther before snapping into a curve. This surface isn't just for looks. It completely changes how the ball behaves, even if the core remains the same. Before leaving the factory, every ball goes through rigorous inspection. Its weight is measured, its size is checked, its balance is tested. If it fails any of these tests, it doesn't leave the factory floor. Only after passing every step is the ball stamped, packaged, and ready for action. Here's something most people never realize. When you throw a bowling ball, that curve, that perfect hook, it doesn't happen by accident. As the ball slows down, the hidden core shifts the rotation just right, forcing the ball to hook at the exact moment. That sharp turn right before it crushes the pins? It was designed long before you ever touched the ball. You're not just throwing plastic down a lane. You're triggering a piece of engineering that was carefully crafted from the inside out. So the next time you grab a bowling ball, remember this. Inside that smooth, shiny shell is science, precision, and smart engineering, all working together for one purpose, a perfect strike. And if this blew your mind even a little, stay subscribed, because we reveal the hidden process behind the everyday objects you thought you knew, one at a time.